Hello everyone, I am Krishna Gupta and welcome to my podcast Krishna Connect. Today we are joined by Asaf Pras, an expert in environmental engineering and technology innovation from Tel Aviv, Israel, with a PhD candidacy in environmental engineering, a master's degree in using artificial intelligence to predict water quality, and bachelor's degrees in mechanical engineering and earth sciences. Asaf brings a wealth of knowledge. Currently serving as the CTO of DataPond, he leads research and development projects including designing rain catching systems and researching water contamination risks. So, Asaf, can you tell us more about yourself and your field of work?
Yeah, thank you very much, Krishna. It's a great honor being here.
Thank you.
I think you said everything about me. I'll maybe add I'm also a father of two,
Oh, great.
married, obviously. Um, and I'm at my last year of my PhD, so hopefully I'll get through that soon.
Yeah,
Uh,
good luck with
mainly
that. Yeah.
focusing as yeah, mainly focusing as you mentioned on developing water quality
Project.
models and algorithms using AI and machine learning to predict water quality parameters. Actually, most of the research is being carried out in India,
No.
including field research.
Hmm.
So
Right.
that's, I think, covers
Makes
all of me.
makes sense. I mean, so I'll start off with a very basic question. How can we detect water contamination more quickly and affordably?
Yeah, so there are efforts being made in the research and development of products that will detect microbial contaminants.
Right, right.
Um, one approach uses, let's say, biosensors such as electrochemical or optical sensors to measure the electrical signals or fluorescence or stuff like that. These are probably the most common ways to try to do that.
Right.
There's another more innovative approach that is using DNA-based detection methods.
Oh, wow.
But I think that those, are really early
Like it's
researched
too early to do it. It's too
approaches.
early to implement them.
Yeah. So it will take time to make them,
To improve on
scalable and affordable.
yeah, an affordable one.
I think my preferable approach, which is, when I started it 5 years ago, about 5, 6 years ago, it was
Oh, okay.
quite innovative. It's using the indirect approach that measures the basic parameters of drinking water, let's say,
Okay. Okay.
trying to characterize it with the help of, as I mentioned before, artificial intelligence
Yeah.
to give the results about the water quality.
Yeah.
So, there are quite a lot of approaches. It depends on what way you're trying to take.
Hmm.
Hopefully, all the ways will lead you to the,
Good results. Yeah.
gold standard that everyone is looking for.
Yeah. So you mentioned using AI. So, how does that exactly work? I just want to understand, and others also want to understand. How does that work?
So the basic of it is using a big data approach. First of all, you have to hold quite an extensive data set of water quality parameter tests.
That's
Uh,
true. Yeah. Yeah.
it can be, yeah, so it can be from laboratory tests or maybe from sensor tests that you travel and take. And once you have an quite extensive data set, it's hard to say how much, is making it extensive, but let's say at least tens of thousands of water samples. Uh, After you have that much, you're starting actually to use data science approaches and techniques. If it's, learning patterns by yourself and trying to understand how the water you can characterize it. Then
Yeah.
you need to
Yeah.
choose the right model, trying to predict. Obviously, you need to maybe even at the beginning decide what is your target. What are you trying to
Yeah. What?
predict?
Yeah.
So
Exactly.
let's say in my case, I started with trying to predict fecal coliform concentrations in drinking water. So that
Oh.
was the target. And after that, once you develop your algorithm, you obviously start to evaluate it, trying to see if it really meets a standard that you set or maybe someone else set.
Yeah.
But that's the really basics of it.
Yeah, okay. That's fascinating. It's like a different approach. like AI and water contamination detection are like very different, kind of topics you can say. So I think you mentioned, I think Felical norms, right? Felical. So can you elaborate what those are?
Fecal coliforms,
Yeah.
you mean? Yeah, so fecal coliforms are actually, um, uh, let's say it like this. When your drinking water is leaving your treatment facility, it's supposed to be okay, free of biological impurities. This is because the method they are using, if it's a RO treatment or reverse osmosis, or maybe sand filtration, and at the end of every treatment water treatment facility, uh, they're also adding some kind of a disinfection method. It can be
Oh, okay.
chlorination, or in smaller scales, maybe UV disinfection. But this is how it leaves your system.
System.
But
Right.
in many cases, by the time it gets to our houses, our homes, or maybe public facilities or whatever, a lot of things happens, in the piping system. And if you have a leakage in the piping system, or you have infiltrations or inflows into the water system, and those water or those contaminants that are carried into the system
Right.
might carry in, what is called coliforms. Coliforms in general, it's a kind of a microbial organism.
Okay.
The fecal coliforms are the one, as the name suggests it comes from, um, animals or even humans,
Oh.
feces. Yes, and
Yeah.
obviously those are pathogenic. I think that the most known one is probably the E. coli. That
Yeah. Like, yeah.
Yeah, so E.
Yeah.
coli is a great indicator for the bigger group of fecal coliform.
Yeah.
Um, so those two are used as the golden standard for testing if your water is free from biological impurities at the end of it.
Okay, so you have to use the if you use like a singular, like if you detect E. coli, then you can detect other coliforms also then, basically.
Um, in most cases, if you find E. coli, you'll find more than that, because that's why they're using the E. coli as a great indicator, because again it comes from feces, and let's you talk about animal feces maybe,
Yeah.
but also in the
Yeah.
human feces,
Human growth.
you have trillions of coliforms,
That's true.
trillion of
It's yeah,
by microbial
it's an
bacteria and
unfathomable number.
everything. Yeah, now most of them are fine. They're even good bacteria, good coliform that eventually are helping our body to resist to the bad
That
microbes. Let's call it like
yeah,
that, to viruses and everything. It's part of our biome. But again, some of them are not good,
yeah,
and you don't want to meet them in your drinking water. So that's why they're using it.
that's it. Okay, yeah, I understand. Improve. That's why also improving detection techniques in these places. Can help improve like public health and protect public health more, right?
Yeah, so the common method to
Hmm?
detect E. coli or fecal coliform is actually taking a grab sample. It means that you need to go to the water system, open a
Yeah, and
tap,
sample.
take
Yeah.
a sample, deliver it to the laboratory, put it on a petri dish. It's the same method that they've been using for about 100 years. And
Oh.
if you think about it, in most of the things that we're, touching or doing in our lives, none of them have anything to do with what we did 100 years ago.
100 years ago.
100 years ago, they were still using horse and carriage,
Hmm.
and today we're using electrical cars.
Ours. Yeah.
But the way that they're detecting the microbial contamination in water,
Changed.
kept the same.
Yeah.
It takes at least 24 hours for the whole process to give an answer. It's quite expensive.
Oh,
As I
okay.
mentioned, it's time consuming.
Yeah.
And this is
That's
why
what.
it's being conducted not enough. They're doing it like maybe at the best cases once a week. And this is, if you're trying to think about, some kind of an analogy, you can think about, you're at your home now, right now.
Okay.
Think about it's nighttime, it's dark at your home, all the lights are shut,
Okay.
and you suspect that you have someone in your house, but you don't know who and where, and you have a flashlight that you can only open for 1 second during the whole night. What are the chances that you will find that person?
Great.
So, everyone is actually trying to, when we talk about real-time in situ monitoring, we're actually trying to develop a method to open up the light for, the entire night.
And yeah, so it stays on always, basically. The light should stay on
Yeah.
for a longer time, basically. Yeah, okay, yeah, that makes sense. So, how can technology and international partnerships help solve water contamination issues?
That's a really great question.
Mhm.
Actually, international collaboration, along with technology advancements, can play and will play and is playing a crucial role in addressing, widespread water contamination issues
Okay.
in many countries, and also, let's say, in our case, in India.
Mm.
Um, you know, Eventually, um, it's if you look at it, collaboration through several key strategies, such
Yeah.
as, it can be from research to regulation,
Mm.
technology development, data sharing, pilot
Yeah, that's
projects
very
funding,
interesting.
and
Right.
even policy advocacy. All of these and many more, eventually, um, you know, these are this is the way to develop a more efficient and accessible testing techniques,
Right.
even if it's for fecal coliform or PFAS, which is the hot topic today in the water sector, and not only in the water sector. Actually, in the United States, it's one of the most hot topics
Oh,
spoken out there,
really?
and even invested. But if you ask about how can it advance the technology and the research. So obviously, joint research initiatives is a great way to do it. I really believe in partnerships as one that
Yeah.
comes from the academia,
Yeah. Right.
and
Right. And
along with companies across countries. I think that working together can really develop an innovative with water testing technologies
right. Yeah.
that will be low cost, efficient, and bring some maybe new methods or use existing methods, but find ways to
Improving
really
that.
implement them in large scale.
Yeah, like improve
Yeah,
it.
and now,
Yeah.
yeah. Now, I also a big believer in water digitalization.
Ah,
Maybe just one word about a few words about it. So
sure,
at
sure.
its core, water digitalization involves using technologies, the basic technologies,
Hmm.
and these are like buzzwords, but this is the real essence of it.
Yeah.
Internet of the Things, which is we all know of IoT, AI, as I mentioned before, and big
I would.
data.
Hmm.
When you combine those things together, it sounds again like something that is really trivial because our phone is using all of this. If you have a
Yeah.
Samsung or
Hmm.
iPhone or Xiaomi or whatever,
Yeah.
you already have a single unit device that uses IoT, AI,
Because
big
every,
data, and everything else.
yeah,
But in the water
that's
sector,
absolutely, yeah, that's
we're
very
still not there. So I think we have a big way and a long way to go. But all the technology is there, so you just need to reach your hand,
yeah.
grab it, and implement it.
To implement it. Yeah, I mean, also, like when people collaborate with each other, when many people come together to think about one thing, there'll definitely be something, something, a great idea formed, and,
That's
partnership are important.
that's really sure. Again, I'm a big believer about that.
Yeah,
Um, During my studies, also my master's and my PhD, we
yeah,
have a collaboration with different universities within India. One
right.
of them was Amrita Puri in Kerala,
Oh, okay.
where we conduct, together research, trying to develop new methods to evaluate water quality. using really low-cost sensors combined with serving the people themselves. And we found out really great and interesting results that, by using really basic sensors that
Okay.
cost almost nothing,
Yeah.
paper kits and so,
Oh.
and asking the people themselves about what do they think about their water, you
Hmm.
can learn quite a lot, and it has a lot of, matching
Ah.
between that and the
Yeah.
laboratory
Yeah.
results. You can see
Result.
really great connections between those. So
Wow.
again, I really believe in the collaborations.
Yeah, I mean, it is fascinating. Yeah, that's true. So, how can low cost and real time contamination sensing, real time contamination sensing systems help address water contamination?
So,
And especially,
the first,
especially in regions which have limited resources, right? Like, not maybe in very extremely developed cities, like in places which have limited resources.
yeah, okay, so let's say, first of all, if you want to address and solve a problem, you first need to know about the problem,
That's right.
know if there is a problem, and that's why you need the monitoring systems, testing systems. Now, again, real-time and in situ monitoring systems are needed. As we mentioned before, if you want to open the light for the entire night, uh,
Yeah.
again, in our case, if you only open a flashlight into the piping system in one place at 1 second during the whole week, you won't know what's really happening there.
Oh, yeah.
You might miss a lot of incidents of contamination occurs, without knowing about it.
None, yeah.
And eventually people are suffering from that.
Hmm.
Now, even in places that, have, let's call it, limited resources and infrastructure, I don't see it as a disadvantage, actually. I think, again, let's look at
Right.
India.
Okay.
Maybe India, it's not the perfect case about,
Hmm.
what we're trying to talk about here,
It's
because
okay. Yeah.
India is lacking the infrastructure, but India
That's
is investing a lot of money in building those
building.
infrastructures. So
Right.
India is really a great place to see how this goes together. And this is why at DataPond, we're actually trying, our go-to market is a
Is
place like India, and we're starting at India.
yeah. Yeah.
Because again, eventually, it's much more easier to
Start
implement new
developing,
technologies into
like
new
develop, right?
infrastructure.
That's new infrastructure. Yeah. I mean, also if it's kind of like also like developing country, you can see the different results which come out at each time. Also, so that you can say the data and you can get more data basically. The data
Yeah,
more data you can gather is more. Like yeah.
that's correct.
So how can AI powered devices provide again real time contamination alerts now and locate contamination? Like how can you locate contamination sources in water samples?
So, eventually AI is not really detecting anything. Okay. First of all, you have to use some basic inputs for the AI model
Okay.
that senses something. Again, let's try to talk about something that we are using. So um, the technology that we're using, that we're developing and implementing, and actually in about a week from now, we're going into two major pilots in India,
Okay.
is using sensors such as temperature, pH, conductivity,
pH.
dissolved oxygen, and you know, six sensors at total.
Okay.
Now, these six sensors, along with other data that we are collecting, such as, what is the water, where is the water coming from,
Mm.
and what we call some kind of a geographical indicator.
Yeah.
These are being set as actually feeds the model itself.
Yeah.
Now,
Yeah.
the model itself, eventually, the way that it works, you can think about it characterize the water. okay, in
Oh,
every single, because we are actually giving it some kind of a geographical indicator or feature, what we call it in the data science realm. So it characterized the water in almost every place using how water looks at those places when it's clean, but
right.
also by understanding, other scenarios from different places, how water looks when it's clean, it's clean. Now, whenever the water is going, the water characteristics are being disrupted, and maybe it's because the pH is dropping down and the temperature is rising up,
Up.
or maybe the
Yeah.
conductivity is really, jumps to a different value. That's when the model starts to think, okay, something is happening here.
Sometimes
And again, it has to sit and it sits on an extensive data,
to know
because
that
the
to know,
data,
know the detection, right? Yeah, it has to have data.
yeah.
Yeah.
So because it's seen and studied how water looks when it's not only clean, but also when it's
That's
having,
yeah, it's
in
yeah,
our case,
contaminant. Yeah.
microbial impurities.
Right.
So it's able to give you an alert, and with a probability, what are the probabilities that the water is really contaminated.
Okay. So it
So that's
essentially
again
doesn't
a
like
little
detect.
bit.
Yeah. So it essentially doesn't detect it. It like just gives like a probability of how much bacteria could be there if it is there or it is not there, essentially.
Yeah, so again, in my case, my first model that I studied and developed, and published a paper about that,
Oh, okay.
was we actually used a really basic. We tried to make the problem more simple.
Okay.
Uh, you know, Eventually, when you talk about fecal coliform, we're talking about concentration.
True.
But if
Right.
you go to the WHO standards, you see,
Yeah.
and all over the world,
Yeah.
obviously in India, but also in Israel,
Yeah.
drinking water should contain no fecal coliforms, zero.
Like zero.
And that makes it really easy because you can look at it as a binary problem. Uh, Zero is good for drinking. Above zero, it's
And
bad for
bad
drinking.
for drinking. Yeah.
Yeah, so the first model that we developed was did actually this with great accuracies. The second model that is
Right.
still under development, and I hope that we'll finish it within the next month or so,
Okay.
and also will be published as a paper. Um, is doing something a little bit more sophisticated,
Oh,
but again, it's not predicting a value, a continuous value, but it's predicting, it's what we call in the data science, it's a classification model.
okay.
In this case, we're,
Okay.
again, by the WHO standards, you can divide the values of the fecal coliforms into 5 groups, what is
Oh,
called contamination risk groups. Each group has a different
effect you can see on the
a
water.
connection,
Yeah. It's
yeah, connection
different effect.
about if you'll drink this kind of risk group,
Then
what are the odds that you will really
yeah,
get
what are the
sick
problems?
or even
Yeah.
die from it? So this is the second research that we are doing, and hopefully that at the end of the process, we will be able to predict
Yeah.
a continuous value with high accuracies. But that's probably the most difficult thing
The
to
bit
do.
difficult part. Yeah. I mean, still,
Yeah,
using AI to even to detect, even to get return a probability is already revolutionary, to be honest. It's still
yeah,
amazing. It still sounds crazy, I'll be honest. It sounds very
yeah.
unique.
Yeah, it's actually quite funny. I started it as back at 2020,
Oh,
maybe 19, when the Corona,
yeah, coronavirus. Yeah, yeah,
Corona
yeah.
19,
Right, right.
uh, you know, uh, um, broke through in Israel,
Mm.
and there was those things that they put at our everyone at their homes, so you couldn't go out. And I thought, okay, I
Yeah.
have data. What can I do with it? And I heard about that thing, AI thing. So I started
Um,
learning about that, day and night.
2020, you
Yeah,
started. Oh, wow. I'm pretty sure
and
90%
then I got
of
like really
people.
great results. not the results that we have today, but I looked at it and I thought, this is really interesting. I presented to my today she's my PhD advisor, but back in those
Oh,
days she was
okay.
my MSc supervisor
Supervisor. Okay.
and my master's supervisor. And she looked at it and she like back at those days she didn't know anything about
Yeah.
AI and machine learning, and she was like, okay, it looks great, but how it works, I don't get it. How can it be? How is
How
it
can it be done?
possible?
Yeah, exactly. Yeah.
I think that for the first maybe 2 to 3 years, that was
They can
the
observe
main thing that we heard from people.
like what
This is
the
not
yeah,
possible.
not
It
possible.
doesn't work
Yeah.
like this.
Yeah.
But
We
I
can
think that
prove
that
them
the
wrong. You prove them wrong.
yeah, I think that during the last maybe year and a half or two, we are starting to see that people
Their mind.
change
Yeah.
their mind. And I think actually that we need to say thank you to OpenAI's ChatGPT for
Ah,
that, because people saw that
because after
okay, AI
chat,
can do really great things,
yeah,
and
after
maybe this guy has something. So thank you, Sam Altman.
after the chat GPT boom, everything was just AI. The world was just
Yeah,
AI.
so I think that everyone, after ChatGPT,
Hmm.
it that was the tool that convinced everyone that,
Yeah,
AI is
that
not
was like a
just
starting point.
a
Yeah,
buzzword. It's really
exactly.
doing amazing things. So, if you can ask it something and it will give you the answer for anything,
Anything, like
um,
anything.
why we can't do that with water? So
Hmm.
again, thank you, OpenAI.
I mean, again, you said you came across AI in 2020. I'm pretty sure like even like half of the world's population hasn't even heard the word AI before 2022. You can see when ChatGPT launched in December of 2022. I mean, I myself
Yeah, yeah.
started even hearing the word AI right after ChatGPT launched because all of us school teachers and maybe all of us students were going crazy that we can use ChatGPT to order.
Yeah, yeah. Again, ChatGPT is like it's a real. They nailed it. They really nailed it. Before that, AI was just a crazy people buzzword. But
Second word, yeah.
since then, I think like everyone really understands the power and the potential of it.
That
So
much, that's true. Yeah. So now, how does DataPond's real-time management of water contamination work, and how does it improve on like traditional methods?
yeah, so we already spoke about how the model behind it works and the sensors that we are using.
Yeah.
The way that DataPond see, the way to use our technology right and to fulfill its real potential, it's by what we call using stationary sensors. That means that you
Okay.
implement those sensors into the piping system in the
Right.
key locations.
Hmm.
It can be at the outlet of the water treatment facility, maybe major piping junctions near you know public buildings and places like those. And eventually, when each one of those devices is monitoring the water again for basic parameters.
Right.
It sends by the IoT. It uses IoT or cellular
Hmm.
devices connectivity to send the data to our cloud. In the cloud, we are having all the algorithms and models that process and pre-process and post-process and all those words.
Okay.
But eventually, they give you your answer about, again, in our case, the biocontamination. It sends it back to the operator. The operator can see it via his cell phone, or
Yeah.
if
Yeah.
he's sitting at his office, he will have a management
Right.
system
Yeah. Yeah.
software. So that's how each one of them
Right.
work. But we're talking about not implementing one, but what we call a fleet of sensors,
Detail, yeah, a
and
lot of stuff.
that's where you really get, that's when the sum of the parts are actually valued more than the sum
Ah,
of
okay. Yeah.
the sum itself.
Hmm.
And that's because if you're having many sensors in your water network,
Yeah. Yeah.
in your water scheme, so even if one of them, again, we're not talking about a system that, you know, um, sends the water with a 100 accuracy performance. Okay, hopefully we will be there one day.
Yeah.
But if you look at the single sensor, it's not there yet. But if one sensor along the way is raising a red flag and says, "Okay, I think we have here contamination,"
Mhm.
um, but all of the other sensors
Sensors,
are
yeah, so they're
not
clashing, as they're clashing,
showing
yeah.
anything. So you
Yeah.
have here
Mm.
only two options. The first option is that that sensor is right and all the others are wrong,
Okay.
but
Yeah.
that's not like that's really a really low probability for that to happen. A
Still,
second
it's
option is that again
clashing,
it's right, but
and
something is happening along the way. Maybe even the pipe is so broke that water is not getting to the other sensors. And that is something that you can see if you're using our system. If you're using our system and water is not going through the pipe at those locations, you'll know about it. And so you stay only with one option, that single sensor is wrong.
so,
And this is really easy for us to see it, for the
oh,
software to understand it, and just not raising the flag at that option. Okay, so it won't give you
okay, 100%
a false alarm.
yeah, yeah. I mean,
So it helps to maximize and optimize the whole sense, like the whole system performance. And as you're using more devices along the pipeline, you'll just have a better
yeah,
accuracies.
that's true. I mean, if you use more sensors, I mean, that problem will definitely occur if you use too many sensors. You never know what can go wrong. It's still a machine. You can say a small mini machine in the end only. So stuff can
Yeah,
it can always go wrong. You never know. Hmm. So no,
that's
fine.
right.
Cool. Yeah. So wrapping up now, what are the potential challenges and barriers? The challenges like maybe you face or DataPond faces in implementing advanced water tech quality monitoring technologies.
Yeah, that's a great question for the end. So thank you for that. Actually, one of the biggest challenges in the water sector, it's again, the water sector is a really conservative sector. Eventually, and I can understand it, eventually, water utilities, water providers are providing us, such a simple
Hmm.
product, like probably the simplest product that you're using
Yeah,
throughout your day, every day.
every day.
Um, but as it's such a simple product, it's
Hmm?
probably the most unique product. It's
Yeah,
probably the
that's
most
that's true. Yeah.
undervaluated product
Hmm.
because without water you cannot
You cannot live. You cannot live.
exist.
Yeah.
And if you drink bad water, not safe water, you'll probably not last long.
Yeah.
So, they have to be conservative, and they have to use caution when it comes to new ways to monitor the water. So again, I think that the main challenge that we are facing today, it's the conservative approaches of
Yeah.
implementing new technologies like this one.
Yeah, that's true. Hmm.
But again, I think that, as we mentioned before, we had the help of ChatGPT that help
Yeah, yeah, yeah.
explain people the power of
Power.
AI and how
Yeah.
it really has the potential to change our lives.
Usable. Yeah.
And I think that people, are starting to understand that we have to find new ways to monitor the water and
Hmm.
not only use that petri dish that, people used
Use
again
all the
more
time.
than
Yeah.
100 years ago.
Hmm.
So I think that this challenge can be cracked, and I hope that
Yeah.
we will crack it soon.
I mean, if we have this technology with us, why not use it? I mean, it can improve our lives, right? It can improve everybody's life, actually, almost everyone in the world. So, if we have the chance, why shouldn't we use it? It's like right in front of us.
Yeah,
We just have
yeah,
to
that's how I see it. We just need to convince everyone else.
convince everyone. Exactly. Because, only when people come together, then something only can really happen then.
Yeah,
Okay.
that's exactly that.
Thank you so much, for talking today. It was amazing talking to you. Thank you for sharing your
Thank you very
insights.
much.
Sure, everybody loved
It
listening to
was
you.
my pleasure.
Thank you so much again. Bye.
Bye bye.